Good morning, my dear friends. Welcome back to my YouTube channel, Coding with Vinod. Today, I am going to discuss a Leetcode March 9th problem on alternating groups 2. Let us see problem statement. There is a circle of red, blue titles. You are given an array of integers of colors and an integer k. They have given colors array. Colors of array. Let's see what this colors of I represents. Here, the color of tile I is represented by color of I. Every element in colors represent the color of the element. Color of I. If it is in colors of I, if the element is 0, then it represents red. If the element is 1, it represents blue. This is the now. Let us see the condition. An alternating groups is every k contiguous tiles in the circle with alternating colors. In this statement tells that we should find out the how many alternating number of colors are present. That means if we have 0, 1, 0, 1, it is alternating colors. Here, after these two elements, same color is representing. That means these two are alternating colors, and these two are alternating colors. These two are alternating colors. Similarly, now we should return the number of alternating groups in the colors of I. Let us see the example. Here another point. Note the since colors represents a circle. Here one thing, remember my dear friends, when they said circle, we should represent in using circle shape 4, 5. If they say what is the seventh element in this array, that means seventh element in this array means we should find the remainder to find out the seventh element in an array, that is 2. 1, 2, 3, 4, 5, 6, 7. The seventh element is 2. We have got. Whenever they say if any array is represented in circular shape, then for finding out the element, we use modulo operator. We use modulo operator. Remember, it is an important point. If the given array is in circular array. Let's see. Now we shall see an example. Let us see an example. Given colors array is equal to 0, 1, 0, 1, 0. Now, given k is equal to 3. Given k is equal to 3. We should find in a block of 3 elements, it is a block of 3 elements. How many alternating colors are present? How many alternative colors are present? That means yesterday we have discussed, if they say on March 8th problem, if they say any block, we can approach through using sliding window for optimal solution. For optimal solution, we can go through the sliding window concept. Sliding window. Now, let us see brute force approach for this. Brute force approach to this, given 0, 1, 0, 1, 0. Given colors is equal to 0, 1, 0, 1, 0. And they have said it is in a circular shape. Now, clearly understand it is a brute force method. It is a circular shape. We can have any number of elements on this side. Let's repeat these elements again. 0, 1, 0, 1, 0. So on. It is circular in shape. is circular in shape. Now, let us see block of three elements in this. It is first block, it is second block, it is third block, it is fourth block, it is fifth block, it is sixth block, it is seventh block, and the blocks will be repeating. Now, observe clearly in this block how many alternating groups are there? One. Now, in this block, how many alternating groups are there? Two. Another one. That means 1 plus 1. It is second group. In this block, we have another one. 2 plus 1, 3. In this group, we have 3. Now, for this group, no alternating groups are there. In this group, no alternating groups. Now, let us see here clearly. In this group of elements, no alternating groups because 0, 0, no alternating groups. Now, observe clearly, my dear friends. Here, after this will be the block of elements. This will be the block of elements. For this block of elements, this white color and this element is repeating. For k is equal to 3, this green color block and this block will be repeating. So, we should stop up to these elements. We should stop up to these elements. For the next block, we should stop. Now we have added how many number of elements? Extra lay, we have added 2. For some number of n, we are adding k minus 1 number of elements. For in a circular path, we are adding k minus 1 number of extra elements. Extra elements, we are adding k minus 1 number of extra elements. This is important. Next, we have gone through the brute force approach. For every block, we are getting for each 3 block of elements, we are finding the alternative groups. How many are there? For this, result is equal to 3. Result is equal to 3. Let us see whether the answer is correct or not. Answer is correct. It is 3. It gives the 3 number of output. These are the alternating 0, 2 and 2, 4 and 0, 2. 2 is the alternating element. 2, 4 is the alternating element. Here we have seen that we have 3 representation. Here the time complexity is O of n into k. N is the number of elements, and k is number of block size. Here time complexity is nearly equal to O of n square. But here understand k will be less than n only. For every element, k will be less than n only. Now let us see the sliding window approach. How this sliding window will be used to solve this problem. Sliding window or optimized approach. Sliding approach or optimal approach. Given colors array is equal to 0, 1, 0, 1, 0 and k is equal to 3. Yesterday I have discussed how can we approach to the sliding window approach. First of all, we assume left as 0 and right as 1. We assume left as 0, right as 1 and result is equal to 0. Now let us see for this example. We shall see how this is left element, this is right element and result is stored here. Result is equal to 0. Now we see if these two elements are equal. If these two elements are equal, then left is equal to right. Left is equal to right. Because these two elements are same. We have no alternative to find out the alternating groups. So if condition 1 is, we have observed that condition 1, this how we approach to this problem is write down the conditions. Condition 1, if left double or array of right modulo n double equal to, because modulo n, because we are using an circular shape array. So we use modulo n for any number of element of R, we get in the range of 0 to n only. Next, and array of R minus 1 modulo n. If both are equal, no alternating groups. We can equal left and right. We can make left and right equal. Now, next condition. When block size for incrementing of, here we shall see, here it is not equal. So we increment right. Now right is pointed here. For calculating the block of window size, right minus left plus 1. I have discussed yesterday why right minus left plus 1. For it is to represent the block size. If we have reached the block size element, if we have reached the block size element, so we increment result. If they are having the alternating groups, here we have alternating groups, so we increment result. If R minus L plus 1, if R minus L double equal to K. If we have reached the block size element, then we increment result plus 1. We increment result plus 1. If now we have reached the block size element, now we should increment left, we should decrement left, and we should increment the left to plus 1. If R minus L plus 1 is greater than K, if block size element is greater than K, then we increment left plus 1 plus 1. These are the conditions. Now we will approach through the problem state. Problem example. Given example is 0, 1, 0, 1, 0. I have said we can increment up to the array size elements of k minus 1 up to k minus 1. Given k is equal to 3, we increment the values up to 0. 2 elements. We add again 2 elements. Now, for k is equal to 3, initially left is equal to here, right is equal to here. When right is less than n, we increase the right value. In this block of elements, we check the condition whether this element and this element is same, not same. So we go to the second condition. Right minus left. Let me write the index elements. 1, 2, 3, 4, 5, 6, 7. These are the index elements. Right minus left plus 1 double equal to k. 2 minus 1. 1 plus 1 is not equal to k. So this condition, second condition is also false. Now let's see the third condition. R minus L plus 1 is greater than k. 1 is not equal, 1 is not greater than 3. So this third condition also false. Now we increment right value. For if we increment right value, let's see first condition. Array of right minus 1. Whether these two are equal. No, these two are not equal. Now let's see the second condition. Right minus left plus 1 double equal to k. it is not of block size. Right minus left, 3 minus 1, 2 plus 1. It has got the element size, block size. So we increment 0 to 1. Now this third condition is false because 3 is not greater than 3. We increment right value. We increment right value to here. Now we will see whether these two elements, array of right minus 1 and array of right is equal. Now this, it is 0, it is 1, not equal. So we increment the here right minus left plus 1 is greater than k. Here we can see 4 minus 1 plus 1 greater than 3. Third condition is false. So we increment left to here. Left to here. Now for the next iteration, right will be here. Here we see right and left are, whether it is, these both are same. Right, array of right minus 1 and array of right. Here this is the condition. This is the condition. We will see whether these two are equal. No, these two are not equal. These two are not equal. So we will see next condition. If these are block size are same, yes, block size is same. We increment result to 2. We increment result to 2. Now we will see for the next element. Oh, I forgotten. For this, we should check for this also. 4 minus 2 plus 1. That is result. Result array is double equal to 3. Here also we increment 3. For the next iteration, we increment right to the next element. Increment right to the next element. Now, here the block size is exceeding. So we increment. Third condition tells that we increment left. We increment left. Here array of right and array of right minus 1 both are same. So now right comma left points to the same. According to condition 1. According to condition 1, it's array left right minus 1 and array of right are same. Then we will say that left and right are equal because no alternating groups are there. Now we increment right to the next element. We increment right to the next element. We will see array of right and array of right minus 1. Both are not equal. And right is not right minus left plus 1. It is not of block size element. It is not of block size element. And it is not greater than block size element. So we shift this right to the next. Since the condition given that R is from the range of 1 to n plus k minus 1. Now the range of R is exceeded. So after all iterations, we return the result value. We return the result value as 3. I think all of you have gone through the yesterday's sliding window approach problem. How can we, if you see this yesterday's sliding window approach, today will become too much easy. Just incrementing, we should remember the conditions like right minus left for attaining of block size. Just remember, or we can calculate. I think this is the optimal approach in which time complexity for this is O of n. Time complexity approach is O of n and space complexity is O of 1 because we never used auxiliary space. Auxiliary space. Now let us see code for this. This is the today's problem. Initially I have said, let me keep board aside. Initially what I have said, initialize the values. Int left is equal to 0. Int result is equal to 0. Initialize the values. Now int left is equal, int n is equal to colors dot length. These are the function to calculate. Now initialize right is equal to 1. 1. Now right value is from 1 to n plus k minus 1. Right plus plus. We increment right plus plus. Now first condition is if colors of right modulo n, if both are equal, colors of right minus 1 modulo n, if both are equal, we will say left is equal to right, because no alternating groups in between them. Now if we attain the block size element of k size, if right minus left plus 1 plus 1 double equal to k, if we get double equal to k, then we increment the result value, result plus equal to 1. We increment the result plus 1 because we have attained the array size and having the alternating groups. We haven't kept that is not equal to 1 here. So this condition will be true. If the block size is greater than k, if block size is greater than k, if block size is greater than k, we increment the left. We should increment the left array. If block size is exceeding the k value, we increment the left to attain block size. At last, after all iterations, we return the result. Let us see whether this will be running or not. Colors dot length. It is colors dot length. Variable or, it is not or, it is right. It's right. We should go through the errors. Here small. I have previously kept or as right, right as or, so it has thrown an error. It is accepted and it will also get submitted. So I think this approach and sliding window approach and brute force method how to solve this problem is clear to all, and I hope you have already subscribed to my channel. Subscribe, my dear friends, and share with your friends. Subscribe and share with your friends. Thank you. We shall meet again on the next day. And thank you. Have a good Sunday. And I hope all are waiting for the Champions Trophy final match. Let's see who wins, India or New Zealand. Thank you.